On this problem, Beep Beep claims to have cookie power. That means he believes that when he eats lots of cookies, he can make coins, when he flips them, land mainly heads or tails. So one day he eats a lot of cookies and he flips 10 coins. 7 of the coins land on heads, meaning there's 3 tails. The question is, do you think that this is strong evidence that he has cookie power? You look at it, and he got most of the coins to land on heads. The way that we're going to test to see if this is strong evidence that he really does have cookie power is that we're going to calculate the probability of getting an outcome as extreme or more extreme than 7 heads when flipping 10 coins. And the way that we're going to do that is with a binomial distribution to calculate the probability. So what does this mean? As extreme or more extreme than 7 heads? That's the key phrase. Well, first of all, looking at just heads, 7 heads, 8 heads, 9 heads, 10 heads is more extreme than 7 heads. So we need to include those 4 outcomes. But 7 tails is just as extreme as 7 heads. So 7, 8, 9, 10 tails would be just as extreme. So that converted to heads, which we're looking at, 3 heads, 2 heads, 1 heads, or 0 heads would also be just as extreme. So we want to calculate the probability of getting any of these 8 results, any of these 8 extreme results that are just as extreme as what he got, to see if that's not very likely. And if the probability of getting this outcome is less than 5%, i.e., p less than 0.05, we're going to conclude that he probably didn't get this outcome by chance, and he must really have cookie power. However, if the probability is greater than 5% of getting such an outcome, we're going to remain skeptical. So what do we want to calculate? We want to calculate, we want the probability of getting exactly 0 heads, 1 heads, 2 heads, 3 heads. Now that's at the low side. 7 heads, 8 heads, 9 heads, or 10 heads. Now we're going to use the binomial distribution to calculate this, and we could do it a couple ways. We can do the adding up each 8 terms. So if we do Control U, adding up each of 8 terms, Control U, and we go down here, and I'm going to type in the formula here. I'm going to put in a single apostrophe so it shows up as text, and I'm going to do 0 equals binom distribution, and we're going to start off with the probability of getting 0 heads out of 10 coin flips, where the probability is getting 0.5 is 50% of getting the heads, and we're not going to do this um, uh, cumulatively. So we're going to put false there, and then we're going to add another term. And so this is, but let's copy. Let's go up to here, and let's keep. We don't want to keep typing everything in. I'm going to copy that phrase, that part of it. Control copy. Now I'm going to go back down here, and I'm going to copy it into itself. So I'm going to do Control V, and so we're going to add the probability of getting 0 coins. I'm going to change that to 1 coin out of 10 flips, where the probability is 50% of getting ahead, and it's not cumulative. I'm going to do it again, copy, paste again. I'm going to change this to 2, go over here, Control V, and I've got 3. Now we could have done a cumulative for getting 3 heads or fewer there, but I'm copying out all 8 terms, so we don't have to worry about the cumulative part. So Control V. Now I'm going to change this to 7 heads out of 10 flips, and do another one, and go for 8, and another one, and that'll be 9, and then a final term, Control V. Now we don't need that last plus sign, so I'm going to delete that and change that to 10. And that will be our equation. So it's quite a long equation here. It goes on and on and on. Now I want to copy this. I'll do Control A. Let's see, it didn't work. I'll copy it all there. Control copy. And let's put it over here. Control V. And I want to get rid of that quotation mark. And press, now it's a regular Excel equation. I press enter and it gives me 0.343. So what is this? This is, I'm going to put the P equals. So Control I, P to get it italics, Control I to turn it off, space, equals. And so there I've got a P equals. Let's make that right justified. So P equals 0.3473. Let's reduce some decimals. So P equals 0.34. That's the probability of getting any of these 8 terms is 34%. And ooh, that's pretty high. So what we need to do is we have to say since P, Control I, P, Control I, is greater than 0.05, we remain skeptical. That means we retain the null hypothesis. Maybe beep beep doesn't have cookie power. So that would be what we have to remain using our hypothesis testing logic, where if we get a result that has less than a 5% chance of happening by chance, we find evidence for our hypothesis, which was beep beep having cookie power. Here, it's quite likely there's a 34% chance that he could get a result that extreme with just one coin flip. So maybe he doesn't have cookie power. We're going to be skeptical on this one.